In the previous video, we discussed about assignment problem with the public endowment. In this video, with an example of office allocation, I'm going to introduce assignment with the private endowment. So please record the Christmas gift example from the video 4. They were allocated the gift in this way. That was efficient by serial dictatorship mechanism in the order of the CBA. But 3 months later, their preference have been changed. So let me think about whether this current assignment is efficient or not. A now assigns W and B assigns X and C assigns P. A can be better off by taking P, and P is now belongs to C, but C doesn't like W. So this cannot be a blocking pair. For Bob can be better off by taking P, and P is belongs to C, and C prefers X, so they can find a blocking pair in which both players can be better off by switching the gift. So now, by switching their gift, B taking P and C taking X, both players can be better off. So this assignment is blocked by B and C by switching their gift. So the induced assignment by the blocking pair B and C is now AW, BP, and CX, where B and C both have been better off. So this is not efficient. So let's think about serial dictator algorithm in the order of ABC. So A comes first, A takes P, and B takes X, and C takes W, because X and P both are not available. So this serial dictator algorithm gives them an allocation of AP and BX and CW. So is this efficient? Yes. As we studied in the previous video, we know this assignment is efficient. So the one can be better off without harming anyone else. But is this fair? So we can see initially Chris endowed with the P, but with this assignment, now Chris gets W, which is worse than P. So by participating to this mechanism, Chris has been worse off. So this may not be considered fair. So the serial dictatorship algorithm is an efficient assignment, but someone may end up with an object less preferred than her endowment. So this serial dictatorship algorithm may not be individually rational. Now let's consider another preference. As before, Alice endowed with W, and Bob endowed with X, and Chris endowed with P. Is there any blocking pair? A can be better off by taking P, but C, who currently owns P, is not going to be happy with W. And player B wants to take W, but A is not going to switch W with X. And C will be happy with X, but Bob is not going to switch P with X. So there is no blocking pair. So is this efficient? Although there is no blocking pair, but there might be some room for improvement. So for instance, Alice takes P from C, and Chris takes X from Bob, and Bob takes W from Alice. So this kind of a cycle makes them have their most preferred item, right? With this profile, the efficient assignment is AP and BW and CX. So everyone has been better off, although there is no blocking pair. So no blocking pair may not be enough for efficiency. If there is a blocking pair, then of course the assignment is not efficient. The assignment can be improved with that blocking pair. But even though there is no blocking pair, an assignment may not be efficient because a trading cycle can make them better off. So this is an assignment problem with a private endowment. As before, we have a set of individuals and a set of objectives. And each individual has a preference over the objectives, and objectives have no preference, but each individual is endowed with some objectives. So with public endowment, individual rationality is trivial because anything is better than nothing. But with the private endowment, individual rationality could be a real concern. Formally, individual rationality requires that each individual should not be worse off by participating that algorithm or that mechanism. So we are going to introduce an algorithm to find an efficient and individual rational assignment that is called top trading cycle algorithm. As the name suggests, we are going to find a trading cycle in which individuals point their most preferred objective available. And then the individuals in the cycle switch their objectives in the direction of their pointing and they leave. Repeat this to find trading cycles. No matter who starts first, there must be a cycle. And this algorithm gives us an efficient and individually rational assignment. So this is our example of office allocation. So we have 9 professors in the department. They already have their own office, but they do not like the current allocation. Their preferences are as follows. So for instance, Professor 1 prefers Professor 7's office the most, and Professor 6's office next, and so on. Okay, so let's Professor 1 point his most preferred one. So P1 is going to point 7's office. Okay, and then 7 is going to point 9's office. And 9 is going to point Professor 2's office. And Professor 2 is going to point 4's office. And then Professor 4 points 7's office. Now we have a trading cycle. It starts from, for instance, 2, 4, 7, 9, 2 again. So we have a cycle. The starting point doesn't matter. So we have a cycle. So now 2 have 4's office, 4 has 7's office, and 7 has 9's office, and 9 has 2's office. all the members in this cycle have been better off because they are going to take their most preferred office. All right, and they are going to leave. And now let's start with the Proposal 1. And Proposal 1.7's office, but the 7 is not available because the 7 is a member of the previous trading cycle. And not available. Next, P1 is going to 0.6. 6 is available, 0.6. And 6 is going to 6 cannot choose 7, and now 6 is going to choose 1. So we have another trading cycle. So in this cycle, P1 takes 6's office and 6 takes 1's office. Of course, both have been better off. And let's find another trading cycle. Now P3 is still in the mechanism, in the algorithm. So Proposal 3, P3 point 6 not available, 2 not available, 8 is available. So Proposal 3.8 office, and 8 is going to point the most preferred office available, which is 3. So we can find another trading cycle. And in this trading cycle, both player 3 and 8 has been better off. All right, and there's only one left. Proposal 5 cannot point 7, 1, 8, 4, 3 because those are not available. The only available office is his own office, so he points himself, and it's just a single person cycle. So Proposal 5 should stay in the same office. So we have found 4 trading cycles, and each cycle makes some of the player have better off. And this is efficient. And of course, this is individual rational because they have option to remain in their initial office. You may think the order might matter. So for instance, Professor 5 wasn't happy with this allocation, so he wants to start first. So let's go for Professor 5 first. So he points 7, and 7.9, 9.2, and 2.4, and 4.7. And 7, we have a cycle. Okay, in this cycle, five is not part of the cycle again. And the cycle 7, 9, 2, 4, 7, that is exactly the same cycle what we found in the previous algorithm with the starting Proposal 1. So we can find another cycle after 7, 9, 2, 4 leaving. Okay, let's start from P5 again. So P5 point 7 is not available, point 1, and P1.7 but not available. Now P1.6 and 6.1. So we have a trading cycle, but again, that 161 does not include the Proposal 5. So we can eliminate this 1, 6 again, and let Professor 5 choose again 5.8 and 8 points not available, not available, not available, but 3 is available, 0.3, and 3 points not available, not available, 0.8. So we have another trading cycle, which is 3, 8, 3. But again, P5 is not part of this cycle. And again, P5 should remain his initial office. In fact, the top trading cycle algorithm gives us more than efficiency and individual rational. It gives us the core allocation. You can remember that core is efficiency plus coalitional rationality. Coalitional rationality means any coalition, including each individual, should not be worse off by participating. In the assignment problem with the private endowment, the core assignment is unique. And importantly, the top trading cycle algorithm is the unique core assignment. No matter who started first, it gives us the same assignment, which is in the core. So we have a quiz assignment with private endowment. The players are endowed with the objectives according to this. So A is endowed with W, and B is endowed with X, and C is endowed with P. And consider this particular assignment, and please check whether this is efficient and individual rational and pairwise rational. And please find a core assignment in this problem.